Alright, today we're going to learn how we can easily derive the quadratic equation. The quadratic formula used in solving quadratic equations. And basically, there are four methods of solving quadratic equations. The easiest is factorization method. We have completing the square method, quadratic formula, and then graphical method. But today we're going to learn how we can derive the quadratic formula. And to derive the quadratic formula, we need to be familiar with the general form of a quadratic equation, which is as squared plus bx plus c, and quadratic equations are basically always equal to 0. Now, a is the coefficient. Now, coefficient is the number in front of an algebraic term, right? Or the number multiplying the algebraic term. So a is the coefficient of x squared, while b is the coefficient of x, and then c is the constant term, no algebraic term, right? Just a number with no algebraic term attached to it. So we're going to learn how we can do that. And if you follow through this video to the end, you will learn how to derive the quadratic formula, use it in solving, and then you also learn completing the square method, because we have to complete the square in order to get the quadratic formula. And this is the quadratic formula right there. So at the end, you're supposed to get minus b plus or minus the square root of b squared minus 4ac divided by 2a. Alright, so let's derive the formula. The first thing we need to do is to rearrange. We need to move this constant term to the other side, and that's the first step in completing the square. So we are going to have as squared plus bx equal to the positive c crossing becomes negative c. Now, next we're going to do is we're going to divide through by a, to make the coefficient of s squared unity. We want to eliminate that a so that we just have s squared on its own. And the only way to do that is to divide everything by a, so a can cancel a. And then we now have that s squared plus bx over a equal to minus c over a. Now, the next thing to do is we now have to add half of the coefficient of x squared to both sides. Now, what I mean is that, first of all, what is the coefficient of x? Now, x and s squared are not the same. This is x, while this is s squared. Now, the coefficient of x is the number in front of x, which is just b over a, right? Now, this is the coefficient. Now, what is half of it? What is half of it? We just have to multiply this by half to get half of it. So we have b over 2a. So this is half of the coefficient. And then finally, we square it. That means we just raise it to the power 2. Then this is what we have. So we're going to add it to the both sides of the equation. So we have s squared plus b over 2a. Sorry, let me just write. I want to write the one we have already before we do this one. So first of all, we have bx over a, and then I'll add half the coefficient of s squared to both sides of the equation, and that's what we have there, plus the same thing, b over 2a squared. Now, the next thing we have to do here is we're going to factorize this, and this is very simple to factorize because this is basically sum of two squares. I think I went high a little. Oh my god. Okay, let's just go slowly. So this is just factorization of sum of squares. So we're going to have this x, then plus the other square there, b over 2a, and then raised to power 2. Now, if you expand this, you get back this, right? That's just difference, or sum of squares. We have a square here, I have another square, and I have another term in the middle, raised to power 2, and then just collect this x plus this. If you open this now, this will be x raised to power 2. We have x raised to power 2 plus 2 times the whole of that. That's 2 times b over 2a, then times x, plus then b squared over 2a. This is how to expand. And then finally we have s squared plus 2 can cancel 2, so we have b times x is bx over a plus b squared over 2a. You see that we have basically the same thing here again. So that's just how we factorize it. So let me get rid of that so we can continue deriving the quadratic formula. So this now will be equal to Now I want us to solve this. Let's try and solve this. So this will be minus c over a plus, now let's distribute the square to both sides, to the numerator and denominator. So we have b squared over 2 squared is 4, and then a squared is a times a is a squared, right? So let's solve this. The LCM will be 4a squared. Now 4a squared divided by a will be half 4a left. So 4a times minus c will give me minus 4ac plus 4a squared divided by 4a squared is just 1. 1 times b squared is b squared. Remember, is equal to x plus b over 2a raised to the power 2. Now I just want us to rearrange this equation. So let me just leave this the way it is. Is equal to, now I want to write the positive term first, which is b squared, then minus 4ac divided by 4a squared. Now we're just going to move this raised to power 2. When we move it the other side, it becomes the square root. So it now becomes the square. Now I need to make the square root a little bit bigger, because we are taking both the square root of both the numerator and the denominator. So let me make that a little bit bigger. Yeah, it's better. B squared minus 4ac divided by 4a squared. Alright, let's keep going. So that we have x plus b over 2a, and that's equal to, now from the laws of sort, we don't want to take the square root of the numerator, so we just leave it that way. So this is b squared minus 4ac divided by, now the square root of 4, the denominator, we're taking the square, right? So, or rather, let me just write it again. So this is now the square root of 4a squared. This is obtainable in source. When you have the square root of a fraction, you can differentiate. You can have the square root of the numerator and then the square root of the denominator. So that's what we have there. So finally, x plus b over 2a is equal to, now we just leave the numerator that way, and let's get the square root of the denominator. Square root of 4 is simply 2, and square root of a squared is 2a, so that we have x now equal to minus b over 2a. Then because of this is a quadratic equation, we're expected to get two answers, so it becomes plus or minus square root of b squared minus 4ac all over 2a. Now note that we have a common denominator, which is 2a, so we can now finally say that x is equal to minus b plus or minus the square root of b squared minus 4ac. Because of common denominator, we just use 1 all over 2a, and this is the quadratic formula. So you don't have to cram it, you just need to learn how to use the completing the square method and some kind of factorization techniques, and then you always have your quadratic formula. So that's